Okay, it's time for another installment on the power supply, and I've received my batteries a few days ago. As you can see here, I got 15 of these batteries, but I'm not going to use all 15 on my power supply. I'm going to use 6 cell per rail of the power supply, so I'm going to be using 12 of these. As you can see here, I don't know how good that shows on the camera. Here we are. Just turn this off. No, keep that on. Here we go. 2200 milliamp at 20C 3.7 volt, and these don't have any protection circuitry here, nothing whatsoever. They just got the 2 taps, negative and positive. As I mentioned before, these can handle, discharge rate of 44 amps. So you need to be very careful with these. For the little tiny batteries that they can, they got a lot of current behind them when you're discharging them. So you need to be very careful not to short these, or when I'm putting on the power supply, I need to make sure that I've got some sort of circuitry to prevent anything happen to these. So what I've done here, as I mentioned before on the previous videos, this is one of the protection circuitry for the batteries. Obviously there's 6 here, so for 6 for the cells. So each section of here there is under voltage cutoff, and there is temperature sensor. So the temperature sensor will be sensing individual cell, the temperature of individual cells. So if they go above whatever I'm setting it, I need to just do a bit of research to find out what's the good temperature for these to stay at, or anything above, then this will cut off. So the way this will cut off is it will cut off only the positive rail. So the positive will connect here and it will come out of here, and then goes to the rest of the circuitry. So if this circuit senses the temperature of this, or the voltage of this if the voltage is gone below 3.1, it will shut off. It will energize this relay and it will cut off the positive. Or if the temperature of the battery goes up, then again it will shut off the positive side. So this is for 6 cells for voltage, under voltage and temperature sensing. And what I've done, I've made another circuit here for over voltage protection, because as I said, I bought these these are the charger for the individual cells. So obviously there's 6, so this is for one rail and this is for another rail. Now I connected these and these work perfectly fine. They're alright, but just to be on the safe side, I needed something to prevent the batteries receiving anything above 4.27, which is the charging voltage for these batteries. So what I've done, I've made this circuitry here, and this will connect to the main charger voltage. So they may basically connect to the positive side here. So the voltage for the charger will come into here and then go out of here into here. So if everything is okay and everything's fine, then this relay is not energized and the voltage will go through the chargers and it will charge everything fine. But once this circuit detects that the voltage of individual charger section of this power supply is gone above 4.27, it automatically energizes this and cuts off the voltage to the charger and stops the batteries being charged. You also got a little alarm here, so if that happens, then the alarm will come on and indicate that the voltage on the cell is gone up, and then I need to obviously turn everything off and find out what's happening in the power supply. This will connect into this, and this will connect into this. Okay, let's just talk about this for a second. As you know, on my previous power supply I was using these voltage displays. As you can see here, these are little voltmeters. The problem with these is they are a bit jumpy, and it's about 100 millivolt or 150 millivolt out, so they're not that accurate. So what I've done is I've made my own voltmeter based on an ICL 7107. And the good thing with this is I can calibrate this, because I've made the circuitry myself. Unfortunately with this I couldn't calibrate it. There was no pot or anything like that to calibrate this. So I've calibrated this using my voltage calibrator here. I use this to calibrate my voltmeters and stuff like that. This is very accurate. So I've used it to calibrate this, and this worked perfectly. This works really good. So what I've done, I've just if you go into this, download the datasheet for this IC, you can see that they have their own little circuit there to make a little voltmeter, and that's what I've done here, as you can see here. So I've got 6 of these. I've got 2 for individual rail of the power supply, so one showing current and one showing voltage. And then I got another two that connects into this circuit and connects into this circuit. Now what is this circuit? This circuit is a little counter. Basically it counts from 0 to 6 and then again resets back to 0 again. And you can see here I've got individual relays here and I've got individual pin headers here. What's going to happen is I'm going to have individual cell of the power supply connecting to individual relays here, as you can see here, just to show you how you will connect, like so. So each cell will connect to individual pin headers here, and out here I will get a voltage of whatever this relays is energy. So this relay, this basically is like a counter, so it goes into this, then it goes into this, then this, then this. Basically it just counts here and then again it goes back to 0. So that way I can sense the voltage of individual cells of the power supply. Now I got this here which connects to the end of here, and then I have a little display that shows me individual voltages of the individual cells on the power supply. So this is continuous. This just goes through the 6 cells and then goes back again and goes through the 6 cell. But this will only come on once the power supply is on the charging mode. So once the power supply goes into the charging mode, all of this circuitry will come on, and then it will show me individual voltages of the individual cells that are being charged. Now at the same time that this is connected here, this will connect into this to prevent over voltage charge. So once it's checking individual voltages, if any of those voltages are above 4.27, it shuts off the power to the charger, and then the alarm will come on and indicate that yes, there's something wrong with the charger circuitry, check it out. So that's basically what I've made. You can see here, very simple. I got a 555 as a pulse generator. It goes into a 4017 counter, and then the counter goes into a relay driver, and very simple circuitry as you can see here. And these are relays will connect both negative and positive to this pin over here. So once this one is energized, everything is off. Once this goes off, this energized, and then the power will go into here. And once this one's off, this one come on, and then power will go into here. So that's how it works. So I can sense the individual voltages of the individual cells with this voltmeter as well. As you can see here, I ordered some LED displays which just came through today. So just quickly made it up, and it works. This is really bright. So once I'm gonna put it behind my Perspex plexiglass, it's really good visible. These are orange, kind of ambery orange, so I thought it'd be nice to have. And this, as I said, this is the over voltage protection and the alarm that I've made. Very accurate. I've tested this with again with my little calibrator. So this has been calibrated right now with this little pot that you can see here. So anything above 4.27, it will shut off, and the alarm will come on to indicate that the over voltage has been occurred into the power supply. So I think everything is done at the moment. So what I'm going to do is next thing I need to do, I just need to wire everything up and put it into my enclosure and start making build the power supply, basically step by step. There's quite a bit involved into this. I didn't know this was, this is how I was gonna go and build this. As I thought at the beginning, the whole project was like, okay, I'm just gonna make a circuitry, connect a couple of these in series together, and then have a tab selector to select which voltage I want out. But then once I start reading about this, then I decided that this needs to have a temperature sensor on them to make them safe. These need to have under voltage protection on them to prevent the batteries from discharging, below its rated voltage. Also, these need over voltage protection, so then I had to make over voltage protection. Then I wasn't happy with the accuracy of this, so then I had to make this out of it. Then I needed to check the individual voltage of the cells, so this is what I've made here. So there's as I went forward with this build, it made sense that I needed to have all of this circuitry to make having these batteries, and to, because these were that cheap. They were like, I think about £2 each, so actually more than £2 each. I think they were three something each. So it pays to prevent these from damaging, getting damaged and stuff. So this is going to be the power to my power supply. So I need to make sure that they stay good for a long time. So that's what I've done so far. And as I said, next is just wire everything together and put it into my enclosure and test everything and make sure everything's working. This was another circuit that I did with the diode, with the fuses that connects straight to the tab of the batteries. But I've made another circuit which I'm just gonna etch it. I haven't etched it yet. The thing with this was gonna connect those wires gonna come out of here and connect into this. I decided once I did a better test on these. I shorted this for a second and the wire just disappeared. So I decided it's not a really good idea to have wire coming out and going into into the fuses. So what I've done, I've made another circuit that this connects straight to the fuses first, and then out of that goes. So if anything happens, then the fuse just blows, and then there's nothing else that connects this to the rest of the circuitry. So that's what I've done. Once I etch that, then I'm going to start with the build the whole thing that I've done. And I think that all the circuitry and everything is done now. As you can just bring it down here. So there's no more circuitry to do. Everything is done now. And as you can see here, this is one of the voltmeters. And I've got, as you can see here, I've got 5 more here. So as I said before, I need 2 for each rail of the power supply. I need 1 for current and 1 for voltage measurement. And then I'm going to have 1 here to measure the individual cells to connect into this circuit. And I've got 2 of these circuits here. There's another one, I haven't populated it yet, as you can see here. So this is for 1 rail of the power supply, and this is going to be for another rail of the power supply, as you can see here. So yeah, as I went forward with this build, the things just got bigger and bigger and bigger. And now I've got God knows how many PCBs, how many circuits I've got into this power supply. I could have just bought a single chip that did everything, but I like to just build things as what I've got with all the resource that I have in hand. I didn't want to order another chip and just waste money and stuff like that. So I decided to just use what I've got. It was more fun anyway, trying to figure things out and make things work, and it was quite a fun. I've learned a lot in this build, in this project. I've made a lot of circuits that I've never made before, so it was quite a nice learning experience for me. And I'm glad to say that it's almost finished. So all the circuits are done. All I gotta do is just put everything into the enclosure and connect everything and build it. So thanks for watching. Like the video, give a thumbs up, and until next video, goodbye.